In this video, you will learn about significant figures and scientific notation, their rules, and their addition, subtraction, multiplication, and division. So let's start with significant figures. Say, for example, we're given this number here. Let's identify each of the digits here. So these digits or zeros that are before the non-zero digits, these are called the leading zeros. And those zeros in between non-zero digits are called in-between zeros. And those zeros after those non-zero digits are called trailing zeros. Then we have the non-zero digits. Now let's discuss the significant figures rules. But first, what are significant figures? So these figures are the number of digits in a value, often a measurement, that contribute to the degree of accuracy of the value. So here are the rules for counting significant digits. So all non-zero digits and any zeros contained between non-zero digits count or are significant. Say, for example, we have 300042. So all non-zero digits here and the zeros in between the non-zero digits. These are the zeros in between the non-zero digits. They are significant. So in this case, the 300042 digits, we have 6 significant digits or 6 significant figures. Okay, the next rule for counting significant figures is that leading zeros are not significant or they don't count. Say, for example, we're given 0.00034. Okay, these are the leading zeros and these are our non-zero digits. It says leading zeros are not significant. So in this case, we only have 2 significant digits or significant figures. Okay, the next rule is that trailing zeros are significant or they count if there is a decimal point. Say, for example, we have 0.0002500. So the trailing zeros here are these ones. And they count or they are significant because we have a decimal point here. Therefore, in this case, this number has 4 significant digits or significant figures. Then the next rule is trailing zeros may or may not count if there is no decimal point. So we go with the most conservative answer. Say, for example, we have 190,000. And these are our trailing zeros. So in this case, the trailing zeros are not significant. So we just have 2 significant figures or digits here. Now let's add and subtract some numbers with significant figures. So when adding or subtracting numbers with significant figures, the answer should have the same number of decimal places as the limiting term. And the limiting term here is the number with the least decimal places. Say, for example, we're going to add these numbers, 1.457 plus 88.2. Again, when adding or subtracting, we round our answer to the least number of decimal places. So in this case, the first number has 3 decimal places and the second one has 1 decimal place. So this is the least a number of decimal places. Therefore, our answer should be rounded off to 1 decimal place. So let's add this. 7, 5, 6, 9, 8. So we get an answer 89.657, and we need to round this off to only 1 decimal place. Okay, since the number after 6 is 5, then we just have to add 1 to 6 here. Therefore, our answer is 89.7. Okay, let's try subtracting some numbers here. Let's say we're given 0.0367 minus 0.004322. All right, in this case, the first number has 4 decimal places, while the second one has 6 decimal places. So the first number has the least number of decimal places. Therefore, we round off our answer to 4 decimal places. So let's subtract this. So this is 8. 9 minus 2 is 7. 3, 2, 3, 0. So our answer here is 0.032378. Since the least number of decimal places is 4, then we should round this off to 4 decimal places as well. So our answer would be 0.0324. Okay. 3 here becomes 4 because the number after 3 is 7. It's more than 5. Then we add 1 to 3. That's why it becomes 4. So this is the answer here. Okay, let's solve some more problems here. What if we're given 4.4981 minus 1.26? So in this case, the first number has 4 decimal places, while the second one has 2 decimal places. So the second number has the least or the fewest number of decimal places. Therefore, we round off our answer to 2 decimal places. So let's subtract this. This would be, okay, 3.2381. So we get this answer, and now we can round this off to the least number of decimal places. Okay, since the number after 3 is 8, then we add 1 to 3. Therefore, we can round this off to approximately 3.24. So this should be the answer here. Okay, how about if we're given these 3 numbers here? 104.250 plus 2.2 minus 15.5534. In this case, the first number has 3 decimal places, the second one has 1, and the third one has 4 decimal places. Therefore, the second number has the least decimal number of decimal places, and we should round off our answer to only 1 decimal place. So let's add and subtract the numbers. Now we get the answer 90.8966. Since the least number of decimal places is 1, then we should round this off to 1 decimal place only. Okay, the number after 8 is 9, therefore we add 1 to 8, then our answer would be approximately 90.9. Okay, so what if we add two numbers? One is a whole number and the other one has a decimal place or a decimal. So let's say 23 minus 14.6. So in this case, the first number doesn't have any decimal places, while the second number has one decimal places. Since there is no decimal place after the last significant figure, this one, the least significant figure, which is this one, two significant digits. So the answer cannot have 1 either. So when we subtract this would give us 8.4, and then we can round this off to 8. So the answer here is 8. Okay, what if we're going to add two whole numbers? No decimal places. So let's say we have 2860 plus 951. So in this case, our answer must be rounded off to the same number of significant figures as the least significant figure, number of significant figures. So the first number has 3 significant figures, while the second number has also 3 significant figures. Therefore, the answer should only have 3 significant figures. So if we're going to add this would give us 3,811. Since our answer can only have 3 significant figures, therefore our answer can be rounded off to 3,810. Okay, what if we're given this one, 2,800 plus 951? In this case, the first number has 2 significant figures, while the second one has 3 significant figures. So the least number of significant figures here is 2. Therefore, we must round off our answer to 2 significant figures. So adding this up would give us 3,751. Therefore, our answer can be rounded off to 3,800. Since the number after 7 is 5, then we just have to add 1 to 7. Now let's discuss the rules in multiplying and dividing numbers with significant figures. When multiplying or dividing, we should round off our answer to the least number of significant digits or figures. So you should not confuse yourself with the addition and subtraction with multiplication and division. For addition and subtraction, you should look for the least number of decimal places, while in multiplication and division, you should look for the least number of significant digits. Say for example, if we're going to multiply these numbers here, 4.36 times 0.00013. So applying the rules of significant figures, the first number here has 3 significant figures, while the second one has 2 significant figures. Therefore, the second one has the least number of significant figures. Therefore, our answer should be rounded off to 2 significant figures only. Multiplying these two numbers would give us an answer which is 0.00056668. Our answer here has 4 significant figures, but the least number of significant figures is 2. Therefore, we should round this off to only 2 significant figures. So this rounds off to 0.00057. All right. Okay, what if we're going to add these two numbers here? 12.300 divided by 0.0230. So again, in multiplying and dividing numbers with significant figures, we look for the least number of significant figures. So in this case, the first number has 5 significant figures. Okay. And then the second one has 3 significant figures. Therefore, our answer should have only 3, or should round off to 3 significant figures. If you're going to divide these numbers, this would give us 534.78261. And we should round this off our answer to the least number of significant figures, which is 3. Therefore, our answer would be approximately equal to 535. All right. What if we calculate numbers that involve both the subtraction division and addition subtraction? So let's say, for example, we have 2.487 times 3.1629 divided by 4.1926 minus 2.07. So we have multiplication in our numerator and we have subtraction in our denominator, and overall we divide. So we just have to apply all the rules here. So let's take a look at the denominator here. It is subtraction, so we follow the rules in calculating numbers with significant figures in addition and subtraction. So that would be, we round off our answer to the least decimal number of decimal places. So in this case, the first number has 4 decimal places, while the second one has 2 decimal places. Therefore, the answer for our denominator should have 2 decimal places because this is the least number of decimal places. Okay, multiplying our numerator, this would give us a 7.8661323, and then our denominator would give us 2.122. So our denominator here should be rounded off to, our answer here in the denominator should be rounded off to 2 decimal places. So our answer should only be 2.12. And if we're going to divide this one and this one, or this one and this one, we follow the multiplication and division rules in calculating numbers with significant figures, which is to round off the answer to the least number of significant figures. So since our answer in the denominator has only 3 significant figures, therefore our final answer should also have 3 significant figures, since it is the least number of significant figures. Therefore, our answer should be rounded off to 3.71. And now let's discuss scientific notation. So scientific notation is a way of expressing numbers that are too large or too small to be conveniently written in decimal form. Okay, what are the rules for scientific notation? So the base here, this one, should always be 10, and the exponent here must be a non-zero integer, which means that it can either be positive or negative. So it can be positive 6 or negative 6. And this coefficient here, the absolute value of the coefficient is greater than or equal to 1, but it should be less than 10. Now, how do you write a number in scientific notation? What are the steps in doing so? So the first one is we find the original location of the decimal. We determine if the number is positive or negative, and then we move the decimal point until it creates a number between 1 and 10. Then we count how many times you moved the decimal. Then that would be our exponent. And it depends where you move the decimal to, or whether you moved it to the left or to the right. So the number of places decimal point is shifted indicates the numerical value of power of 10. Say for example here, we're given this number here. Okay, this number doesn't have any decimal point, so we can assume that the decimal point is at the end of the number, and then we can just move it to make the coefficient less than 10 by following the scientific notation rules. So we can move from here, so 1, 2, 3, 4, 5, 6. So we can write our decimal point here. Since we move 6 times to the left, the shift is to the left, therefore the algebraic sign of our exponent will be positive, and we write how many times we move our decimal point. So we moved it 6 times, therefore the exponent of our base is 6 multiplied by the coefficient, which is 4.5. We can just neglect the zeros here in writing our scientific notation. And how about if the shift is to the right? So if we move our decimal point to the right, the algebraic sign of our exponent would be negative. So the same thing, we count how many times we move the decimal point, but the exponent of our base should be negative. Okay, so for example, this problem here is 0.00453. So we have our decimal point here, that one. So we need to write the coefficient as between 1 and 10. It should be greater than 1, but less than 10. So we can move our decimal point to the right, 1, 2, 3. Then we write our decimal point here. Then that would give us 4.53 times 10, our base, to the power of 3, because we move it 3 times. And since we move it to the right, therefore the exponent is negative. So that would be 4.53 times 10 to the negative 3. Okay, how about these ones? Okay, we have here 123.00. And let's write this in scientific notation. So our coefficient should be, take note that our coefficient should be greater than 1, but less than 10. So in this case, our decimal point, we should move it to the left. So there will be 1, 2. Our decimal point will be between 1 and 2, and this would give us 1.23 times 10, which is our base, and we moved it 2 times. Therefore, exponent here is positive 2. So moving to the left, moving the decimal point to the left, the algebraic sign of our exponent would be positive. Okay, how about the second one? We're given here 0.00123. Our decimal point is here. Therefore, we can move it to the right. So 1, 2, 3. And this would give us 1.23 times our base 10. How many times we move it? 1, 2, 3. 3 times. And we move it to the right. Therefore, the sign of 3 is negative. Oh, this is 3, 1.23. Okay. And now let's discuss addition and subtraction of numbers with scientific notation. So how do we add and subtract numbers with scientific notation? So when adding or subtracting numbers in scientific notation, the exponents must be the same. And so when the exponents are the same, we can just add the coefficient. Just take note that before adding or subtracting, we need to transform all the powers of 10 to be the same. Okay, say for example, we're given this problem here, 3.4 times 10 to the 5th plus 9.7 times 10 to the 6th. Have you noticed that the two numbers have different exponents? The other one is 5 and the other one is 6. So all we need to do is rewrite the numbers to have the same powers of 10. Okay, we can either write this one to the power of 6 or we write this one to the power of 5. Whichever is more convenient for you, then you do it. So in this case, I will rewrite this one to the power of 6. To make this, to turn 5 to exponent 5 to 6, we need to move our decimal point to the left. Because shifting to the left, that would give us a, that would add to our exponent, exponent of the base. So moving the decimal point to the left, or 1 point to the left, this would give us 0.34 times 10 to the 6. And now the two numbers have the same exponents, then we can add them up. So 0.34 times 10 to the 6 plus 9.7 times 10 to the 6. We can just add the coefficients. So the coefficients are 0.34 and 9.7. We can just add them up. This would give us 10.04. And then we rewrite this in scientific notation. Therefore, our answer would be 10.04 times 10 to the 6. Again, by following the scientific rules that our coefficient should be greater than 1 and less than 10. So we need to write this as 1.004 times 10 to the 7th. We just move our decimal point to the left. Okay, how about we're given this problem here. We subtract 6.071 times 10 to the negative 6 minus 8.2 times 10 to the negative 5 minus 0.521 times 10 to the negative 4. Okay, we notice here that the three numbers have different exponents of their bases. So we have negative 6, negative 5, negative 4. Now, following the scientific rules, scientific notation rules, when adding and subtracting numbers, they have to have the same exponents. Their bases should have the same exponents. So what we're going to do here is rewrite the numbers. So I'm gonna rewrite these numbers here, the two numbers here, to have an exponent of negative 4. So we can just directly add up the coefficients and solve the problem. So for the first one, we have an exponent of -6. In order for -6 to become -4, we just have to add 2 here. So that means we move the decimal point to the right 2 times. So that'll be 1, 2. And we add 0 here. So this number would become 0.06071 times 10 to the -4. Okay. The next number is -5. So in order for this number to become -4, we add 1. So we move our decimal point to the right once. So that would be 1. So this number would become 0.82 times 10 to the -4 minus 0.521 times 10 to the -4. Now our numbers have the same exponents for the bases. So we can just add up all the coefficients. Okay, it would be 0.06071 subtract rather minus 0.82 minus 0.521. Okay, and this would give us an answer of -1.28029. And then rewriting this as scientific notation, our answer would be -1.28029 times 10 to the -4. Okay, but let's not forget the rules of significant figures when subtracting numbers. Okay, so we still follow the rules. When adding and subtracting, we round off our answer to the least number of decimal places. So the least number of decimal places is 2. Therefore, we round off our answer as -1.28 times 10 to the -4. So this is our final answer. All right, so how about when we multiply and divide numbers with scientific notation? So in multiplying numbers with scientific notation, the powers of 10 are added in multiplication, while the powers of 10 are subtracted in division. So our law of exponents here applies. Let's try some sample problems here. Let's say we're given 1.23 times 78.9. Again, okay, this should be 123. Sorry. Again, by following the scientific notation rules, we should write our numbers. Our coefficient should be greater than 1 or less than 10. So we can rewrite 123 as 1.23 times 10 squared. So we move 2 decimal places to the left, and that would give us a positive exponent for our base. So our decimal point would be here. And for the other number, our decimal point is here, so we move it to the left also 2 times to the left. Oh, no, once because 7 is less than 10. So our decimal point would be here. So that number would be 7.89 times 10 to the power of 1, or just simply 10. And now we can perform the operation. We can multiply 1.23 times 10 squared times 7.89 times 10. And this would give us an answer that is 9.6 70 times 10 cubed, because we just have to add the exponents in when we multiply scientific numbers with scientific notation. Okay, how about if we're going to divide these two numbers, 123 divided by 78.9. Again, we can rewrite this number as 1.23 times 10 squared over 7.89 times 10. So in division, we apply the law of exponents, we subtract exponents. So this would give us an answer which is 0.156 times 10 to the 1, or just simply 10. So take note that in multiplication and division, we still follow the rules of significant figures, the list of significant figures. So in the first one, 3, and then the second one is 3 as well. Therefore, our answer also has 3 significant figures.